How does the polarization voltage delta V relate to the differences in voltage between the initial and steady states, and what does it indicate about the energy barriers that ions must overcome during the electrochemical process? How do the electrode/electrolyte interfacial impedances R0, EI, and RSS contribute to understanding the dynamics of ion transfer at the interface? And why are these measurements important for optimizing the interface between the electrode and electrolyte? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How do changes in R0, EI, and RSS over time reveal information about the evolution of the electrode/electrolyte interface during cycling, and how can these values be used to predict system stability? What is the significance of R0b, the AC impedance in the initial state, and how does it help characterize the behavior of the system under alternating current conditions, especially in the early stages of measurement? What information does the AC impedance provide about the resistance to charge transfer and ion migration in the system? How does the mobility of sodium ions, TNA+, influence the overall performance of the system? And why is understanding ion mobility crucial for improving charge/discharge rates in sodium-ion batteries? What factors might affect TNA+, and how can these influences be mitigated to enhance ion transport and battery efficiency? How can these parameters, initial and steady-state currents, polarization voltage, interfacial impedances, and sodium-ion mobility, be used together to develop a comprehensive model of electrochemical performance? And how can they guide the design of more efficient energy storage systems? How do changes in these parameters over time inform us about the long-term behavior of the system, and what does this imply for real-world applications such as the life cycle and stability of batteries under continuous cycling? How can Na ion mobility be determined from the line width in a 23 Na SSNMR spectrum? And what does the line width represent in terms of the dynamics of ion movement within the electrolyte? Why is 23 Na SSNMR a useful tool for studying sodium ion mobility? And how does it provide insight into the local environment and interaction of sodium ions in the system? How do SSNMR techniques help to identify the conductivity of typical anions like 19F in electrolytes? And what role do these anions play in the overall conductivity of the system? How does the ability to detect anion conductivity with SSNMR contribute to a deeper understanding of the ionic transport properties in the electrolyte? And why is this important for optimizing electrolyte performance? What are the advantages of using SSNMR over other techniques in characterizing ion conductivity? And how does it provide more detailed information about the ionic species involved?